So today we're going to have a look at sequences. And your learning goal, by the end of this, you'll be able to write an algebraic expression based on a sequence. So first part's really easy to do. In fact, it was covered in 6th grade. Our new vocab is a sequence is an ordered list of numbers. In other words, they follow a pattern. An arithmetic sequence, which for some crazy reason I call an arithmetic sequence just because I like the sound of it. Each term is found by adding the same term to the previous sequence. Let me show you what I mean. So example 1. Describe the relationship between the terms in the arithmetic sequence 8, 13, 18, 23. Then write the next 3 terms in the sequence. Well, as we go from 8 to 13, the difference between the two is 5. So we're adding 5. 8 plus 5 is 13. 13 plus 5 is 18. 18 plus 5 is 23. That's what we mean by describe the relationship between the terms. Now the next question is, what are the next 3 terms? Well, 23 plus 5 is 28. 28 plus 5 is 33. 38. Pretty basic. Example 2 asks you to describe the relationship between the terms in the arithmetic sequence 0.4, 0.6, 0.8, and 1.0. Well, here we're adding 0.2, we're adding 2/10. We're adding, excuse me, 2/10. We're adding 2/10. So that's the relationship. It increases by 2/10 each time. As for the next 3 terms, 1.2, 1.4, and 1.6. Simple. So pause this, try these 2, then come on back and we'll check it. So, okay. Each time it's going up by 0 3/100ths. 3/100ths. Note, an arithmetic sequence, it's always going to be addition, not multiplication. Multiplication would be a geometric sequence. You'll get those next year, I think. So then we write the next 3 terms. 2 4/10 or 2 40/100ths. 2 43/100ths. And, whoa, better go up here. 2 46/100ths. So on the next one, we're adding 1/4 each time. So, next one would be 1/2, 1 3/4, and 2. Pretty simple. Here's where things get a little bit trickier. So, we're going to look at how we can use sequences to write an algebraic expression. So, example the 3rd. The greeting cards that Meredith makes are sold in boxes at a gift store. The first week, the store sold 5 boxes. Each week, the store sells 5 more boxes. Key fact there. The pattern continues. So this is an arithmetic sequence. Each week sells 5 more boxes, so you can see it's adding 5. What algebraic expression can we use to find the total number of boxes sold at the end of the 100th week? Okay, so we know the first week, underline it here, the first week the store sold 5 boxes. So the position, that's weeks. For the first week, value of the term, that's our boxes. Sold 5 boxes. So we know we've got this sequence. The second week, 10 boxes. Third week, 15 boxes. And fourth week, 20 boxes. Because remember, up here it says each week the store sells 5 more boxes. So we need to find out in the position what operation we use to get to the value. Well, if you look at all of these, 1 times 5 equals 5. Week 2, the position is 2. 2 times 5 equals 10. So that's our operation. We're multiplying each position by 5. Okay. So we know, look at all these, as long as we multiply by 5, we'll get the value. As we multiply the number of weeks by 5. So let's write an algebraic expression. W is going to equal weeks. Here's our variable. Well, pay attention, because this is the important part. As long as we multiply the number of weeks by 5, we get the value of the term. So our algebraic expression is 5 times the number of weeks, or 5W. Because it works. We could plug in any number. Let's plug in 2 for weeks. 5 times 2 equals 10 boxes. It lines up. It's a little busy over there. Oops, I just erased everything. Oh well. So the next part of the question says to find the total number of boxes sold at the end of the 100th week. Well, we've got 5W, our expression. So let's plug in 100 for the number of weeks, and now we know we sold 500 boxes. You try. So if the pattern continues, we've got a pattern here, circles. What algebraic expression can be used to find the number of circles used in any figure? By that we mean this is figure 1. Then this one would be figure 2 and figure 3. So what expression can be used to find the number of circles in each figure? Give it a thought. Melt that brain. See if you can get it. Pause and come on back. Okay. So let's look here. In the figure 1, there's 3. Figure 2, there's 6. Figure 3, there's 9. If you look at how it relates, the number of circles relates to the figure, each time we're multiplying it by 3. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. So we'll say F equals the figure number. And so our expression is 3 times F, or 3F. To answer the second part, how many circles will be in the 50th figure? Well, 3 times 50 equals 150 circles. And that's all there is to it.